Hi all, my name is Abhilash and today we will discuss the SQL based questions from previous years. And if you are new to my channel, please subscribe to my channel and press the bell icon for get notified every time when I upload a new video. And let's go to the computer screen and then discuss there, okay? Now let's discuss this question from GATE 2019. Consider the following relations P, Q and R. There are three relations given and how many tuples will return by the following relational algebra query. This is the query given. And I have just replaced this pi with the pi and the sigma with sg, and others remain the same. And let's check this. We want to first evaluate the subquery first in the relational algebra, these two subqueries. And firstly we need to have this Cartesian product between p and r. Go to the p and go to the r. Okay, take the p dot y because we need to have this p dot y here, and let's also check the r dot y, which is this, and also mark the r dot v equals to v2. First check the r dot v and then the v2 and v2. Okay, and now let's map the p and r based on these following conditions. Okay, now it's time to take one tuple from p and mark with the other tuples to r. Let's take the first tuple from p, which is this one, and let's check which tuple can map to the other tuple in r. Here p dot y equals to y1, so y1 should be marked first here. But is r dot v equals to v2? No, r dot v is not equal to v2, so we can skip to the next. Here r dot v equals to v2, but y condition is not specified because in p it is y1 but in r it is y3. You can skip it, and here it is not true, here it is not true even. And let's check the other tuple, y1. Is it true? No. Is it true? No. Is it true? No. Is it true? No. And let's check the other one, y2. Is it true? No. No. Here it is true because y2 is same in both of them, and also v2 is present, so it can be mapped. Okay, and also check the other one, y4 cannot be mapped with any one of them, so leave it out. Okay, the result of the evaluation, we get this table, and out of which we need to project this pi means that project x here is this one, and we need to project the x, which is x2. Okay, so here it is. Okay, similarly, as the next query, we need to mark the first q dot y and r dot y here like this. Yeah, okay, and also q dot t equals to greater than 2, q dot t greater than 2, greater than 2. Okay, and we need to map the tuples from each relation to other relation. Let's check this. Let's check the first one. Okay, and it cannot be marked because it is not greater than 2, and here it can be marked, but we need to check about the y2. So y2 can be marked with here. Okay, and also this can be marked with this one. Okay, y2, and also this y1 is also mapped with this tuple of the first tuple of r, and we can get three tuples. Okay, three tuples in the result. Okay, now we need to project the x. So x is having three x's, 3x1, but in relational algebra it is kind of set, and set do not have any repetitions. But in SQL you need to add distinct keyword in order to print only single x1. Okay, now here we have placed the x1 in this subquery, and now to evaluate the entire one we have a subtraction sign here. Subtraction means here in set difference. See, it is a set or it is a set. If both are set, we need to add the set difference operator because that is given in the question. So if we subtract the x1 as a set element from this set, we get the same element x2 because there is nothing to be subtracted from this set. Okay, so answer to the problem is x2. And the question I've asked how many tuples will return by the following algebra. It is only one. Okay, so one is the answer. Let's take this question. A relational database contains two tables, student and performance, as shown below. The primary key of the student table is their roll number, which is and for the performance table, their columns, roll number and subject code together form the primary key, which is this one. Now consider the SQL query given below. Select s.student name, sum p.marks from student S. Okay, here S is an instance of the student table and P is an instance of performance table. Both are joined in such a way that where p.marks is greater than 84, and here we want to group them by the student name. Okay, how many names are there? Different types of name. 1, 2, 3, 4. All are distinct, so it will be having 5 different groups of name, which means 5 tuples will be definitely returned by the following query. And let's see the output now, where p.marks is greater than 84. See, here the joining operation would be done on the basis of the primary key of both the tables, but if you notice here, the primary key is not the same. Here roll number and roll number is common to both the tables, but in order to merge them or join them, you need a proper primary key, but there is nothing to be common as a primary key. Roll number here is a primary key, is fine, but roll number is not sufficient to determine every tuple in this table, in this relation, so we cannot merge them like this. So mainly the operation would be done like this: p.marks greater than 84, which are this one, and this one. It will leave out 80 because it is less than the 84. Now it will sum it up. Okay, sum of 452 and place to the corresponding name for each of them. It will show you outputs like this in SQL, MySQL, okay, Oracle. Okay, now let's discuss this one. Consider a relational database containing the following schemas. These 3 schemas are being given. The primary key of each table is indicated by the underline the constituent fields, which is this underline, okay, this one. Select s.s number, comma, s.s name. It means that number of attributes returned in the output would be 2, because 2 attributes have been selected from the supplies S and catalog C. Now in order to solve this one, we need to solve the subquery first. Okay, select average cost from catalog where p number equals to p4, group by p number. So the main thing is we need to take the average cost from the catalog where p number is here, where p number equals to p4, which is this one, and also take the cost of each of the corresponding p4, which is this one, and take the average, which can be done by 200 plus 250 divided by 2, which is 225. Okay, like this. And now let's place this 225 in this query, okay, or in the place of query, like this. Now we will take each tuple and compare with the cost where it is greater than 225. Okay, we need to select, or we to print the s number, which is this one, and s name, which is this one. Okay, and where the cost should be greater than 225. It means that where the cost is greater than 225 is here, this one. Okay, these 4 should be mapped with this one, and this one, because if you map them, it will only one time. So this whole tuple will be mapped with this following tuple, so it will return only 1, and then with this one, okay, and with this one and this one, it will return 4 tuples. Okay, so answer to this problem is 4. And also it is saying that how many tuples should be returned, so it is 4, because the answer to this query is all the result with the mapping of this all the attributes, but how many tuples should be returned would be 4. Okay, now let's check this question. Consider a database that has a relation schema EMP, means employee ID, employee name, department name. An instance of the schema EMP and SQL query is executed on the get. Okay, so here's the execution of the query. Select average ec.num. Okay, what is ec now? Come here. Okay, we have a subquery here, and let's execute this subquery first. Okay, in order to solve this question, we need to have a subquery execution first. Okay. Select department name dot comma count employee ID, and if you see here, we need we have 2 attributes to be printed. So department name and count EMP ID is having 2 attributes. Okay, and it is renamed as EC department name. Okay, means the table returned by this subquery would be named as EC, and the first attribute that would return is department name, and the other is number, which is the count of the employee ID. Okay, now let's check this. Go to the EMP table first. Okay, and we need to group by department. How many types of department are there? AA, AB, AC, AD and AE. There are 5 types of department. Okay, and for each department we need to count the number of employee ID. Okay, let's count the employee ID here. Okay, we have counted the number of employee ID here. So it is 4, 3, 3, 2 and 1. We have written here 4, 3, 3, 2, 1. Okay, this department name is AAAB, ACAD, and this number is 43321. Okay, now this relation can be placed in replacement of this subquery here, and now you need to select the average or print the average of this relation EC from EC, which is this table, where department name comma num, which is this in means we are taking this 4321 as a set, and we are just printing the average of this one. What is the average of this? 4 plus 3 plus 3 plus 2 plus 1 gives you 13, and 13 by 5 is 2.6. Okay, so you can say 2.6 is the answer. Okay, now let's take this question. Consider a database that has relation schema CR, student name comma student name. Okay, these have 2 attributes, and sense of this schema, CR is given below here. CR is a table. The following query is made on the database, which is this algebraic expression. Okay, let's check this. The number of rows in T2 is here, and number of rows it is asking for. Okay, in order to evaluate this, we need to evaluate subquery first. Now select the student name equal SA from the table CR. Let's select the SA first, and now select the student name. After selecting the student name, we need to project the course name. Okay, now project the course name is this CA, CB and CC. Okay, so here we have selected. Now this relation has been assigned to T1 here, and T1 is grouping the CR. Okay, here it means that CR, the whole table, has been grouped by T1. And now on grouping, what is the output that you can expect, or number of attributes you can expect? So the best trick here is write the student name and course name first, like this. Now you can place this course name right below it, and you can just cancel out this course name, and you will left with the student name. So the main thing is student name, and which student name should be appear in the output. Now let's say this. Here the grouping says that if SA can be mapped to CA, CB and CC, which is present in this course name, if this SA can be mapped to 3 of them, we can print SA. And also if you see this, SC is also mapped to CA, CB and CC. Okay, and also CD, all of 3 can be mapped for SF as well. But if you see, SE cannot be mapped because CB has been mapped, but CD is not present in this course name that we have selected before. CD is not present, so we can leave it out. Also CB has not been mapped because CA is not present. CB and CC may be present, but it is lacking with the CA, so we should not print it. So the answer to this problem is SA, SC, SD, SF. Okay, these 4 rows or 4 tuples should be written in the output. Okay, so well, we are done, and please don't forget to subscribe my channel. Okay, thank you.